This is a review of a 9.6 worksheet. First one, if the measurement of angle DBA is 52 degrees, what's arc AD? So DBA, that's here. I'm going to label that 52 degrees. Let me zoom in a little bit. It's 52 degrees, just like it said. What's the measurement of arc AD? Okay, well, this is arc AD right here, right? And this is the angle that intercepts that arc. And we know that that is an inscribed angle, not a central angle. So therefore, the arc is double the angle, the inscribed angle. So 52 times 2 is 104 degrees. Question 2, if arc AE, if the measurement of arc AE is 118, so arc AE, so I'm going to make that 118 right here. Let's use orange. 118. Then what is the measurement of angle ACE? So this is ACE right here. So we know that that is a central angle, and that is the intercepted arc. They are the same measurement because it's a central angle. So therefore, that angle must be the same. What type of angle is angle ACE? Well, we just talked about that, right? So that is definitely a central angle, not an inscribed angle. Number 4, it says in the diagram below, the measurement of angle DBA is 39 degrees. So DBA, I'm going to go ahead and label that 39 degrees. What is arc AD? Well, here's arc AD right here, and here is the angle that intercepts that arc. That is a central angle, therefore the arc is the same measurement. So that is 39 degrees. Next question, what is the measurement of angle DFA? So DFA is this angle down here, right? So that angle down there, angle DFA, look at that. It is intercepting the same exact arc. We know that's 39 degrees. So we know that this inscribed angle is half of the measurement. It is not the same. It's not a central angle, right? So we need to take 39 and divide it by 2, which gives us 19.5 degrees. That's what that angle will be. What type of angle is angle DFA? It is not central. It is definitely inscribed because it's on the circle, right? On the circle. Okay, moving along. I'm hoping that you guys can answer the questions about radiuses and diameter there. Let's look at number 9 here. This is a good question. It says if RT is a diameter, RT, that's a diameter, what is the measurement of angle STR here? STR. Well, that was part of the example I showed you in the video, right? Since this angle STR intercepts this arc, right? Which is half of the circle. So we know that that arc is 180 degrees. How do we know that? Because a full circle is 360 degrees. If I divide it by 2, I get 180 degrees. And that's half a circle, right? Well, then that angle here must be 90 because that's half of that amount, right? And that's the rule with inscribed angles. So 90 degrees. And that's the rule, right? If you have a triangle inscribed in a circle, right, and one of the sides is the diameter, it has to be a right triangle then, right? That's always going to be a right triangle in that case. Moving right along, let's jump up here to number 10. It says if AB is tangent to circle D, what's the measurement of angle ABD? So this angle right here, right? So if this is a tangent line here, which it is, it says it is, that means it touches only once. And then see how it's meeting the radius at the same exact point, point B. We call that the point of tangency. The rule is that this angle must be a right angle, which means this angle would also be a right angle, right? So these are 90 degree angles. Anytime you have a tangent that meets a radius at the same point, it will always form a 90 degree angle. So we say 90 degrees here. Why? Because a tangent and a radius will meet at a 90 degree angle. And we can use this knowledge to find missing measures. So let's look at number 11. It says if AC is tangent to circle B, what is the length of AC? So if AC, right, this line AC, if that's tangent to circle B and there's a radius that connects to it, that means that that has to be a 90 degree angle. So I'm going to mark that 90 degrees, which makes this a right triangle, right? You can see here that, look, the radius is 8. Well, then that means that this radius is also 8. All radius lengths are the same. So I'm going to go ahead and mark that 8. Let me erase this part now. So that is 8. And then it says, what's the length of AC? So we're trying to find the length of AC. So that's just the missing side of a triangle. We already know two sides of the triangle, this side and that side, right? So we can use the Pythagorean theorem to solve for that missing third side. So we're going to say that a squared plus b squared must equal c squared. The missing side, right, the hypotenuse here, this is going to be 17 because I have to add 8 plus 9. So that's 17, and that's our c. Hypotenuse is always c, so 17 squared. So we're going to say 8 squared plus the missing side, we'll just call that b squared. So 8 squared is 64 plus b squared equals 17 squared. So 17 squared is 289. And then we are just going to subtract 64 from both sides. We're solving for b. So 289 minus 64 gives us 225. So b squared equals 225. We're not done solving for b. Remember, we have to undo the square by square root. So if we square root 225, we get 15. So we say b is 15. That missing side we want must be 15. And that is our answer. And moving along, 12 is pretty similar to number 11. You should be good there. Let's do number 13 here. This will be our last one. It says in the diagram below, AC and AB are tangent to the circle D. All right, so if they're saying that but AC is tangent to the circle, see how it meets that radius, and this is tangent to the circle and it meets that radius, so that means that those are 90-degree angles, right? So let's go ahead and mark those right now. That's a 90-degree angle, that's a 90-degree angle. Okay, so we got that. CD and BI are radii, that's what it said. Since the interior angles of a quadrilateral add up to 360, that's pretty important. And angle DCA and DBA are right angles, we already marked those. Then CDB and CAB must add up to be 180. So the point is here is, if this is 90 and that's 90, right? If I add those together, that's 180, right? All four angles, right, on the inside of a quadrilateral always add up to be 360 degrees. So 90 plus 90 is 180. So if we got that 180 out of the way, that means that angle D and angle A across from each other must also equal 180 to make the total 360. So let's answer 13. It says in the diagram above, label the two right angles. We did that. If angle CAB is 44 degrees, so CAB is this angle right here, right? That's 44 degrees. What's the measurement of the central angle, CDB? So that's this angle over here. So we can just say, well, we know they add up to be 180, so 180 subtract 44 is going to give us 136 degrees. And that's going to help you solve 14 and 15 and those as you go kind of move along there. As usual, guys, if you're stuck, let me know if you have any questions.